The methods section is the most important section in a clinical research manuscript. Video 23 established why. If the design cannot answer the research question, nothing in the results changes that. This video goes deeper. Specific questions, specific things to look for, specific red flags. This is video 24 of the Peer Review Mastery series from Zenith Publications. Today, evaluating methods and statistics as a peer reviewer. Methods are the only section a reviewer can evaluate independently of the results. The study design, the sample size, the statistical approach, all of these were decided before the data existed. A reviewer who reads results first has already been influenced by the author's framing of what was found. 3 questions must be answered from the methods section alone, before reading a single result. Is the study design appropriate for the research question? Is the sample large enough to detect a real effect if one exists? Was the statistical approach pre-specified, or does it appear to have been selected after seeing the data? If any of these raises a concern, that concern may be a major revision. The results section does not change it. Research designs sit on an evidence hierarchy. Randomized controlled trials are the strongest design for establishing causation. Randomization controls for confounding variables that could explain the outcome other than the intervention. Cohort studies follow participants over time and are strong for incidence and risk. Case control studies look backwards from outcome to exposure and are useful for rare diseases. Cross-sectional studies capture a single point in time and describe prevalence only. The reviewer's question is not which design is best in general. It is whether the design matches what the paper claims to demonstrate. The most common mismatch: a paper that claims causation from observational data. Cohort and case control studies show association. They cannot establish causation. When a discussion section uses causal language from a design that can only show association, that is a major concern. Statistical power is the probability of detecting a real effect if one exists. The standard in most clinical research is 80% power, meaning if the effect is real, the study has an 80% chance of detecting it at the chosen significance level. A power calculation justifies the sample size. It requires 3 inputs: the minimum effect size the study is designed to detect, the significance threshold, typically 0.05, and the acceptable power level. All 3 should appear in the methods section. 2 major red flags. First, no power calculation. A sample size described as based on available participants is not a statistical justification, it is convenience. Second, an underpowered study with a negative result. If the sample was too small to detect the effect, a negative result is uninformative. The study may simply have lacked the power to find what it was designed to find. A control group exists to isolate the effect of the intervention. Without one, the reviewer cannot determine whether the observed outcome was caused by the study factor or by time, co-interventions, or regression to the mean. 3 types of controls appear in clinical research. Placebo controls. Participants receive an inactive version of the treatment. Active controls. Participants receive an existing standard treatment, comparing the new intervention against what is already available. Historical controls. The comparison group comes from a previous dataset. Historical controls are the weakest option. Baseline characteristics, care standards, and measurement methods may all have changed between periods. The reviewer checks 2 things. Are the groups comparable at baseline, and was randomization adequate and concealed? Statistical analysis is where the most consequential misunderstandings in peer review occur. A p-value below 0.05 means the result would be unlikely by chance if the null hypothesis were true. It does not mean the effect is large. It does not mean the effect is clinically important. In very large samples, trivial effects produce small p-values. Effect size answers the question the p-value does not. How large is the difference? Confidence intervals provide the plausible range of the true effect. Multiple comparisons. Every additional statistical test increases the probability of a false positive. A study that tests 20 outcomes without correction will find at least one significant result by chance. Look for whether multiple comparison corrections were applied, Bonferroni, false discovery rate, or pre-registered primary outcomes. 4 patterns that appear frequently in manuscripts with statistical problems. HARKing, hypothesizing after results are known. Post hoc hypotheses presented as pre-specified. The giveaway. Outcomes that do not appear in the study's registration record. P-hacking. Running multiple analyses until p below 0.05 appears. The giveaway. Many subgroup analyses with no multiple comparison correction and no prior justification. Outcome switching. A different primary outcome was reported than what appears in the study registration. This is detectable when a registration record exists. Missing data. Excluded or dropped participants not reported, or imputation methods not described. Missing data that is not handled transparently can bias results significantly in any direction. Design, sample, controls, stats, red flags, report, the reviewer's sequence for methods. Design, does it match the research question? Sample size, is it justified by a power calculation? Controls, are they appropriate and comparable? Statistics, was the approach pre-specified? Red flags, HARKing, p-hacking, outcome switching, missing data. The central question is always the same. Could this study have produced a reliable answer to the question it claims to address? If yes, evaluate what it found. If no, that is the major concern, and it belongs in the major concerns section of the report. Video 25 covers reviewing figures, tables, and data, the visual and numerical evidence that either supports or undermines the paper's conclusions. Subscribe at youtube.com/@zenithpublications and visit zenithpublications.com for all journals and submission guidelines.